Okay, good afternoon. Sorry for the delay. We had a little issue with our connections, but I'm very pleased to introduce the last session of the week. It is my pleasure to introduce to you Dr. Sachin Shetty. He's an associate director of the Virginia Modeling, Analysis, and Simulation Research Center, Old Dominion University. He's also associated with the Department of Computational Modeling and Simulation Engineering. Today, he will be giving a second talk on artificial intelligence. In this case, he will be focused on drone detection. Without much further ado, Dr. Shetty, if you can please continue.
Thank you, Dr. Gonzalez, and thank you all for your time. And as Dr. Gonzalez said, this talk is focused on artificial intelligence for drone detection, but I do have other topics that I would like to touch upon. So I just learned from Dr. Gonzalez that there was a presentation on artificial intelligence. So I'll provide an extremely brief overview of AI and machine learning. But the focus of the talk is where does AI fail? And how do we build reliable AI? And I will wind up the talk with an ongoing work that's happening in my lab on using reliable and robust AI for detecting drones. So as I promised, I want to just set the stage, level set on definitions. And most of you may have heard the term data analytics. And there are different compartments or different aspects to data analytics. There are ones that are focused on being descriptive, where you describe what has happened. Then you focus on anticipating what will happen. That falls on the predictive. And finally, prescriptive, recommend what to do. So the focus of AI is essentially being in predictive and prescriptive. And that I wanted to level set that because a lot of the things that I'm going to talk about is going to be focused on being predictive and then using those predictions to being prescriptive. Again, definition that there are so many different ways to define this. I want to describe the definitions that are in context to what I'm going to present today. So the AI, as some of you may have seen, such definitions is a discipline that focuses on human intelligence. So incorporating that into computer systems. Most of my work is on machine learning, where I focus on building algorithms that can learn from data and experience it and provide actionable insight. So that those two pieces are key. You learn from data and experience, and in developing those algorithms, you figure out what's the optimal way to integrate both data and experience that will provide the actionable insights. And then there is a subset of that area called natural language processing, which has become an emerging area where how can computer systems learn from language? So that's going to be a huge aspect to, especially from learning from different types of data sets and also experience. Let me talk about the different applications. So most of you have probably seen machine learning from face recognitions. Google and other tech companies have really taken it to the next step in terms of leveraging images from social media and using it for face recognition. You've seen a bunch of applications in the healthcare sector, manufacturing, and so on and so forth. So it's essentially a technology that allows you to ingest data and get your inferences. In terms of the workflow, and this is crucial because when I touch upon where does AI fail, this workflow is going to be extremely important. And so we do need the future engineers and scientists to essentially have this workflow in mind and identify where exactly the threats or the attack surfaces exist, where failures can happen. So at the very left, you have the data generations and acquisition. That itself is a huge challenge. How do we trust that process? How do we know for sure that the data that we're getting is of good quality? And how do we define quality? And is that universal, or is that specific to certain engineering and scientific systems? Once you have gone through that process, which is the most challenging process, Then you have the storage piece, and you probably have heard about a lot of security and privacy issues with data storage. Where is my data stored? Who owns it? Who has access to it? What type of jurisdictional and legal aspects can impact access to my data? And so there are a lot of aspects surrounding it, and there are a lot of avenues where it fails as well. And then you have the process of extracting those patterns, all those algorithms that are in place. And even that process has certain failures attached to it, because when those algorithms are automated, the challenge then is to identify, can somebody modify that algorithm without anybody's knowledge? And if that's the case, you're talking about an automated process that doesn't have the necessary checks and balance. And once you get through that process, then you have the actionable intelligence. So that's a large piece of the puzzle, where decision maker is going to now act upon the insights that are provided. And so again, don't want to belabor the point, but this workflow is going to be something that I'm going to come back over and over on identifying failure and what one can do to address the challenges. In terms of the machine learning workflow, this is the typical workflow that we work with. You identify the needs, you define the requirements, you build the model, you deploy it, and you continuously measure the model effectiveness. And then that's the typical workflow that we use with a lot of different applications. All right, so that's me level setting AI and machine learning. Again, it's a huge topic. There are courses and degree programs in AI. I probably can't do justice in 5 minutes, but I'm now switching to the middle portion of my talk, which is why and where does AI fail? And so some of you may have seen this videos where you have an automated car that is essentially a self-driving car driven by AI. And this is a Tesla car, and for the most instances, uh, it works well. And there have been several videos similar to this. The challenge is, what we notice is most of the times it works well, but then there are times like this. So this is, of course, you see a lot of videos on YouTube where you see the automated portion of the car is not able to differentiate between right there where what's the divider and what's the actual lane. And so the recognition system sometimes is unable, where it almost tries to hit, uh, cross over the barrier or cross over the divider. And this is something that has been done on multiple cases right there, almost about to hit the barrier, but it still was able to get back. So even though in this video it has not been catastrophic, but you can look at other videos on YouTube and you'll notice that there are cases where it has been catastrophic. Now, so the question comes about, right, as to why does this happen? And so the reason for that is that machine learning is less robust than you think. And so here's an example where you have seen images being classified as a certain object or a character, in this case, an animal, but with certain level of noise, and that could be random noise or attacker-induced noise, it can be misclassified as an airplane. And so, and now if you go back to the workflow that I showed earlier, where are the attack surfaces where this type of noise can be induced, whether it's in the data or somewhere in that analysis of the data. And so, we essentially have figured out a way to make pigs fly by using this attack surface. And this is this was a project done by a couple of students at MIT labs, where they were trying to figure out, by just orienting a turtle, it can be mistaken to be a rifle. So that's another example of, the previous one was focused on adding noise. So this is the one where you're looking at different orientations, and then by just changing the angles, it gets classified as a rifle. And so these are scenarios that, again, there are a few more, even the image recognition, where somebody gets misclassified as a celebrity. So, and so what I've shown in the last couple of examples is how just mere rotation and translation can be sufficient to fool a lot of the state-of-the-art models. And so just augmenting enough data does not help the problem. And so, which brings up to identifying, looking at the same workflow that I showed through a reliability lens. Okay, what one can do to make sure that the process is reliable. So you have the data collection. That's the first step. So you got to make sure that our data collection is accurate. Then you have the training where you train the model. So that's the example that I showed you where incorrect training can lead to incorrect classification. And then I showed the third example where you could introduce a non-random noise and create incorrect inference. And finally, when it comes to deployment, you see all these errors getting cascaded, and that can augment and result in additional challenges. So why do we have this problem? And essentially, the problem stems from the design of machine learning, where you learn from examples. So if you see this particular concept, you have different objects. And in a traditional machine learning model, you subject the model to a training process, and then you try to test it. And your performance measure is focused on the fraction of mistakes that you do during testing. However, what happens is there is a huge difference between the training environment and the testing environment, something that you saw in the Tesla example, because you could train the Tesla in several training environments, but then in a real world scenario, the environment is dynamic. The environment throws a lot of curveballs. Can your model be resilient? Can your model be reliable to accommodate those dynamic scenarios? How do you make sure that the real world scenarios are captured in the training environment? And if they're not captured, do you feel that the machine learning model is ready to be presented in the real world? So why are they unreliable? So this is again, I'm definitely not going to have any mathematical equations here. I'm going to keep it at a high level, but conceptually you will understand where the problem really lies. So we are trying to build a robust machine learning algorithm. And so this is the current state of the art, where you're trying to identify a sort of a behavior to characterize your given function. But what happens is you're trying to be extremely rigid about how you define what is when you classify something as a phase when you don't. And so because you're so rigid, even if there are slight modifications there, and if you look at the workflow, it could have happened during the data collection, it could have happened due to several reasons, because it's almost impossible in certain cases to guarantee that the data that you see in the training it will be the same thing in testing, which happens a lot in real world. You've got to have the ability to accommodate certain modifications to the environment, and your mathematical model should be able to accommodate that. And that becomes challenging, right? So when you learn a lot of the mathematical terms, equations, you think about very closed form type of solution where things are very nicely laid out. They look very clean, and in the clean environment, everything works well. But when the environment is not clean, you have to use that same mathematical model, the same algorithm to still work. You cannot keep on changing it. And so that's why the push for the machine learning algorithm to be more robust, where we don't have to continuously try to change our equations or our model to accommodate dynamic changes. And so the reason why we have to be concerned about these changes is that slight modifications create this perspective. Again, sometimes to the human eye, it might look pretty obvious, but for the mathematical model, it never does. And so that's the reason why we need to have some human perspective on understanding and overcoming these challenges. So, for example, if you were to look at this particular image right here, you see a dog and a cat. And if you were a human being, you probably would look at certain features, right? You're not going to look at each and every pixel on this image to try to clarify. What a human does is the human is going to be looking at maybe the shape of the ears, maybe the shape of the mouth, and those would be sufficient to determine the exact attribute or the exact classification. So I look at the mouth, I look at the ear, and that would be sufficient. And so what I'm trying to get at is that, and again, this may work in the image setting. Now, in different settings, we have to grab those type of insights, right? So that's why I was talking about the data and experience, trying to augment that together. And when you classify, when you transform this dog image into a mathematical representation, what happens is you lose all context because you only focused on the pixel intensity. So you're going to focus on the color, the brightness, the intensity, and other image properties. And you will lose all context that this is a dog, whether in a field or a garden, or any other contextual information. And what you see are just pixel intensities. We call this metadata. And so if you don't have those metadata associated with this, then you lose all context. And if your goal is just maximum accuracy, of course, in that pixel intensities, if you're just comparing one pixel intensity with another pixel intensity, the accuracy will be reached. But if the environment changes ever so slightly, it's still a dog. The environment has changed, and you may misclassify it as something else. So I also want to bring about other examples of this issue. So I talked about reliable. So here's an example of the same aspect in a societal type of problem. So for example, uh, if you look at this correlationships and associationships, so if you notice right here, you have the relationship of man being a king and woman being a queen. And you will notice, if you carefully look at all the different associations that you have, you see, he being a computer programmer, right? So that's insinuation that only males can be computer programmers, only females can be a nurse. Um, so this is where we get into the fairness and the unbiased aspects of AI. And so again, the bias comes in from the training data. If you notice the training environment that I showed you, what is the environment under which the data is collected? And the bias is going to set in. And so how do we try to overcome the bias? Or how do we provide the insight based on the bias? And sometimes what happens is the algorithms that you have might amplify the bias, and so one needs to understand how the bias is propagated and amplified. So a lot of the different AI environments, bias and fairness is not understood, and this is a very complex topic. We definitely want to hear more questions from this topic because this is not a well-studied topic, but this requires a lot of attention. And it is hard to solve it because there is no one way to achieve this. But the awareness or the objective of ensuring that one will try to be as fair, as unbiased, given the constraints, or at least be transparent to the bias that was used to create the environment, at least be transparent about that. That will go a long way. And the same thing with privacy preserving. This is a huge challenge. How do we make sure that with a lot of the tech companies trying to collect your data and provide you those machine learning insights, how do we address the challenge if folks don't want to share the data? So if I want to keep the data on my phone and I don't want to share it, but I still want to benefit from the machine learning algorithms and analytics. So what is the middle ground where I want to keep my data private, but I don't want to compromise my privacy, but also don't want to lose the benefits of analytics. So that brings me to the third part of the presentation, which is the application. So I set the stage of what AI is, the workflow for AI, the places where AI fails, and I want to round it all together in a project that I'm doing for the DoD and also other customers, where we are focusing on how do we use a reliable AI technique to detect drones. And so the problem for drone detection is it's a safety problem because the drones sometimes get operated. You can imagine a search and rescue mission. You don't want any interference from drones if they're not authorized. So how do you make sure, whether it's in a search and rescue mission or whether it's in an airport scenario, that you create this geo fence, and to make sure that if any drones that are unauthorized appear in the geo fence, you can alert the authorities immediately. So we built the system again. This is also a brief presentation in terms of the technical details, but I'm going to touch upon some of the concepts that I just talked about, which is focusing on key features. And so we decided not to focus on the physical properties of the drone, the angle, the orientation, and other similar physical properties, but we focus more on features that we feel is going to be difficult for the manufacturers to change. A lot of the manufacturers can change the appearance of the drone and how the drone operates in a physical environment. So we wanted to make sure that we focus on some of the communication type of features, which are the actual signals that are being sent. And we use that as our data for us to separate a drone signal versus a non-drone signal. So very briefly, you have shown similar slides earlier where you had different animals and you create those different classes. The same concept that we used, trying to group the drone signals versus non-drone signals by creating this partitions among the different sets. And so this is an example of that similar partition where the red dots represent the drone signal and the blue dots represent the non-drone signal. So we've been able to achieve that separation. Of course, there are certain instances where it's also challenging for us to achieve the difference. So that's something that we work on. No system is 100% accurate. And so I want to show a quick demo. Again, it's always easy to show this in a live setting. So this is a system loading up. So I'm going to go back to where it's going to start showing you some results. So the system is loading up and it's providing some of these clusters that you see. And right here, this is our machine learning algorithm that's in session. So this is the drone that is right now in off mode, and this represents the signal um, that governs the transmission of the images from the drone. And so this is our actual signal capture right here. So still the drone is off, and so at some point in time, we're going to use the controller to turn on the drone. And so we are capturing all the signals, and right here, the drone is set to a mode where it is about to transmit. And so at the bottom, you will notice the detection. So this is a drone class manufacturer's name is the type of the drone is called Mavic, and that detection takes place because this is where it is transmitting. And this video is basically broadcasted from the drone camera. And so over here, you see all the different drone signals that are being captured. And uh, again, the classification right here. And as soon as the drone is turned off, you will see that the drone signal is cut off and it's no longer classified as a drone. And when you see the class off, which means that it's a non-drone. So this is a work where we were mostly focused on making sure that we have the ability to accurately describe when we have a drone signal, when we don't. And we incorporated all the robustness that I talked about earlier. And if there's interest, I can definitely share more details if we had more time. So I want to quickly, I know we are up against time, so I want to keep the time open for more questions. But I wanted to hit the big picture, right? So AI is a sharp knife, extremely useful, and it's definitely dangerous if you use incorrectly. And you know, the next frontier is to create this trustworthy AI system. So I want to take a couple of minutes to talk about this because this is going to be something that is going to be extremely crucial because we are entering into an age where we have a lot of automation and a lot of AI systems that are part of an automated process. And if we don't have a good understanding of the threats or the attack surfaces where the data can be manipulated, as I mentioned to you, extremely small modifications to the data can result in such a huge difference in the prediction. And so that happens anywhere in the workflow. So whenever AI systems are deployed, starting from the data capture to the data analysis to building the model to even making inferences, one has to look into all aspects. So there are four aspects. You got to look at reliability. You have to look at whether it's fair or unbiased. You have to look at whether you have privacy preserving. And finally, you got to make sure that you can explain the results. The last piece is something that a lot of people don't focus on, because if you don't have a way to explain the results to a human being, then you have all these insights, but not a well-crafted and articulate way of explaining it. And that's the piece that needs to be done. So we need to develop AI that is safe. And I did not focus on safety a lot, but the first example that I showed you, where you had the automated car that was driven by AI, and you notice that if we had reliable AI, then we at least have a guarantee that the AI system will provide the safety. Right now, we don't have the ability to create an AI system that can guarantee your safety. And so that needs to happen. So we need to build AI systems that can, in any scenario, guarantee that the human being or whoever is operating the system will be safe. You also need to make sure that you have the ability to explain the results in a way that can be understood and to be used in other processes or systems. And then the reliability piece, which focuses on are you able to withstand changes in environment? Can the AI system overcome noise that is not seen before in the training environment? Then being able to verify it. How do you make sure that the AI system is going to work? So what type of metrics one can come up with to verify that the AI system is working correctly, right? So if you don't have that insight, then you know it works, but you don't really know if it works as designed. And finally, human ready. And that goes into the explainability. How do you make sure you can explain it? So in the case of the drone detection, you can detect the drone, but you also need to provide explainable insight into under what conditions have you been able to detect a drone? What is the level of trust? What is the level of accuracy? Can you rely on the insight 100% of the time? Or is there some level of leeway or some error associated with that? So that's key for the decision maker to decide whether they can make a decision based on insights they're getting. So I think I'll just stop right here. And again, the big takeaway is that we need to have AI systems that you can rely on, especially in safety and mission critical applications. And I touched upon some of the concepts that one need to build upon. And I showed you an example of a drone detection scenario. I think I'll stop right here and take any questions.
Okay, thank you very much, Dr. Shady. That was a very informative presentation. We have a few questions. The first one from Ana Patricias Islas Maino from Mexico City. She asks, what is the role of artificial intelligence on the Internet of Things?
So the role, and that's a very good question about, I didn't touch upon Internet of Things, but IoT, for the rest of the audience, it's the technology that's going to be providing the ubiquitous access to network. And so the role that AI can play is that, again, comes down to, do you trust the device? So I'll give very specific examples. So if the IoT device is used in a healthcare facility, right? So imagine the IoT device and something that you're maybe, it could be a Fitbit or it could be any wearable type of healthcare device. How do I make sure that the data that's been gathering is actually gathered for myself and not somebody else, right? So what are the avenues where AI can detect that you have taken the device and moved on to somebody else? So you don't want to provide your own data. That's number one. Number two, for AI to look into scenarios where the device is not working very well, right? So either the device doesn't work very well or the environment is not conducive for the device to work. So that's the scenario and issues with using IoT device in healthcare. You can imagine IoT being used in manufacturing, the same type of issues where there's so much dependence on the device to provide accurate information and coming up with insights based on that. So the biggest role is if I go back to the workflow. So if I come here in the workflow, so right here where you have the data collection, so that's the process where AI can play a better role in extracting information from devices, and more importantly, being able to build the model on the device. So that's also a role IoT can play. Can you build the model on the device so that the IoT device is not playing the role of just data collection, but it's also able to build a model so that you don't have to send the data. So you can keep the data on the IoT device. And so the ability for us to build AI models that can work on IoT device, because they don't really have a lot of computation associated with it. So yes, it's IoT and AI go hand in hand, and a lot of this is attached because all the data that we're talking about is eventually going to come from IoT devices. So devices are going to play a huge role. And so I see the AI workflow right here needs to encapsulate that aspect as well, because IoT devices are now created by different vendors. And right now, there isn't a common standard. So everybody creates the devices using their own standard. So the AI technique needs to be aware of that as well.
Okay, thank you. Next question, Carter Monroe from Washington, D.C. Can you please clarify the regulations on AI machine learning from internet data that may or may not be owned by individuals? Are there laws that regulate which data on private individuals is allowed to be used for in AI machines?
So that's an excellent question. So that's the reason why, if you recall, I had this slide on privacy preserving AI. So yeah, so to comment on the laws, the laws are, at least if I focus on, I had to be mindful of the region. So every region has their own laws. I think the laws are much more they're different in different regions. I think Europe has their own laws, and other parts of the world have their own laws. So I would say that there is no universal legal framework that I've seen. Every country or every region comes up with their own laws that are driven by the appetite for maintaining the privacy. So what one has to come up with is a way to incentivize a way to regulate the big tech who are ultimately going to have to adhere to. So I've seen a lot of push happening, but as of now, there isn't a well-formed legal framework that clarifies or clearly describes how data should be used. So I can mention that the trend is moving towards that. I think the Facebooks and Googles of the world are realizing that there's a big push for privacy, there's a big push for protecting sensitive data. So that's the reason why they are working towards, because it's mostly a business opportunity for them, because if more people get concerned about their data being compromised, then they will choose to work with companies who do protect their data. But however, the legal frameworks are very slow in catching up. And so the only way to make the change happen is a business model. For example, if there's a company that can come up with a way to assure your privacy and guarantee that, that's a company that a lot of people are going to gravitate towards, and the market will decide it. But as of now, I haven't seen, at least in the US, strong legal framework or strong regulation. It needs to happen, but it's, at least in the US, it's moving slower than it needs to.
Okay, thank you. A quick question from Arav Singh from Planet Earth. Following up your previous answer, the one before the last one, can you please define again what is an IoT device?
So the IoT, Internet of Things, it's a device that is able to connect to the internet and be able to capture data, process it, and submit it to a cloud or any remote processing center. Now, the reason why the term IoT was defined, because you might wonder that how is that different from your handheld phones, or how is it different from a Fitbit? So they all come under that umbrella. The reason why the term was coined, because a lot of times when you associate devices, you think about a computer, and you think that only a computer, handheld computer, is the only device that can connect to the internet. So the IoT term has been coined to resemble that you could have sensors on your clothes. So I could be wearing sensors on my t-shirt, and that could be connected to the internet. So you can imagine any physical object. So you can imagine, let's say you have a ship with a lot of containers, and I want to track the container. So I can put a sensor on the container, and that sensor can monitor the goods and different pieces that are shipped to the container. So it's a technology that enables any physical object to act as data collection, data processing, and data communication or data exchange. And so that's what the technology enables. So any physical device, you have the ability to use a sensor that can sense the physical environment. So let's say you want to capture the temperature, pressure, or any physical phenomena attached with that physical object. And then you want to, and that's a physical piece. So you can use the same thing for human beings. So if I were to wear some sensor or have implantable sensors, so the same concept. So now the AI can play a huge role, because now we have to process data coming from these devices, and we've got to make sure that we can trust the data that's coming, because your AI is only as good as the data that it's being used or it's using to derive those insights. So in an IoT setting, when you have these devices anytime, anywhere, and not necessarily governed by some strict physical controls, then how do we trust the information that's coming out of that, right? So if you have an enterprise system that is opening itself to IoT, so if I were to wear this IoT device on myself, and I go from one location to another location, how do I make sure that the accuracy and the security of the data has been verified before I send it to an AI system? So it's a very important question, and especially given the fact that the IoT device may not be subject to the same level of physical security and constraints, so that makes it extremely challenging.
Thank you again. Next question. Christian Alejandro Leal Aguilar from Culiacan, Sinaloa, Mexico. He asks, please explain the differences between AI, machine learning, and deep learning.
So AI is the broad discipline where you're trying to incorporate human intelligence in your computer systems. Machine learning, it's the mathematical process by which you actually realize the goals of AI. And deep learning, it's a subset of machine learning, where you, if you remember, when I was explaining machine learning, I was talking about learning using examples. You know, you observe and then you analyze. So with deep learning, you are trying to automate and improve that process of learning from examples, so that you can do that fairly quickly, fairly robustly, and speed up the time in terms of building your model, and increase the accuracy. So you can imagine AI is a big umbrella, machine learning is a subset, and deep learning is a subset within machine learning.
Okay, thank you. Next question. There have been similar related questions to this one. So I'm going to ask for a person in Chennai, India. He asks, is AI better or worse to use than normal human written code to perform the same function?
So when you talk about human written code to written same function, it comes back to how that code was written, right? So if that code is based on strict rules, then I'm assuming those rules are encoding some real life experience. So whatever the logic, if you will, has been converted to code, and now the code is running. So what you end up with is a code that is static. But what it is missing is the observation of real life events, the data. So the code by itself is not sufficient if it's not observing. So for example, if you look at the automated car, so we only had the code that tells the car when to speed up, when to do all these operations, but doesn't have the ability to learn and update that code in real time. So now you end up in a situation where you are very rigid. You can only do what the code tells you to do, but you don't have the ability to accommodate for different situations. So what machine learning does is, so instead of having the strict set of rules, it tries to learn from experience, learn from examples, and so it tries to encode that. And so the premise is we're talking about humans, right? So we are making this conjecture that human beings uh, learn or build their knowledge based on what they observe. So we're trying to figure out how to encode that. So code is part of it. So that's the logic. But then there is value in terms of the experience that you learn from observations, because you still need to have the ability when you talk about think on your feet, learn on the fly. And so how do you incorporate those concepts? Because in real world, you will be subject to dynamic environments. So how do you make sure that you accommodate? So machine learning accommodates that, because that training phase, right? So that's why human beings, when you, let's say you want to become a pilot, you have to train, you got to put in so many hours before you become a pilot. And so that training process, which trains the pilot's brain, we are trying to incorporate that in the machine learning model. So we want the model to see all different types of scenarios. And we hope that in the real world, one of the scenarios might pop up and it knows how to observe, how to perform. So that's the strategy that we use. So that's the difference. So if the real world is static, doesn't change, then yes, you can use the code, because you know that logic will work, because you don't expect any variations in the real world.
Okay, thank you, Dr. Shetty. A local question. Dory McLeod from Chesapeake, Virginia. She asked a question about training AI. She's concerned about face recognition training. How can AI recognize your face if you change what you look like every day? For example, by changing your makeup.
Yeah. So that's a good question. That goes into the reliability piece that I was talking about, right? So if you look right here, when you build those face recognition pieces, so a good example I can give you is right here. So there are a lot of different aspects one could look into determining a face. One of the factors that have been looked into is the distance between your eyes. So you may change your makeup, but there's only so much you can do about the distance between your two eyelids or the facial features. So the actual pixel intensities are just one aspect. But when you do the training, you are going to subject that person's face to different types of modifications. So you focus more on the facial features, not on the color of the skin, essentially. So the facial features then play a bigger role, and that's what happens in training, right? In training, you make the determination because you then pick up the features that, like you said, will not be subject to daily life changes. So that's, you can put makeup, but you have to do cosmetic surgery to change your facial features. Of course, if you do cosmetic surgery, then yes. So that's the situation where the algorithm won't run. So yeah, so in your training phase, you got to make sure that you choose the attributes that will be robust. That's why I keep using the word robust over and over again, because you can't use attributes that are so subject to real life factors and will be changing over time or with lifestyle. So we got to use features that don't change, will be static, but still unique to every individual. So that's true with a lot of human faces. There are certain facial attributes that are unique and can be used to recognize the individual.
Thank you. I have a question from Samira Carter. She's from Stafford, Virginia. And she asks a question, how can AI help predict when will the coronavirus be eradicated?
when it'll be eradicated. So I'm glad that question.
Well, actually, the question is, when will the cure be available?
Cure be available. So it's funny that you asked that question. That I wish I had a slide on coronavirus. As a matter of fact, AI did not do extremely well in the COVID pandemic, and the reason for that, no data, right? We didn't have enough data on COVID that helps train the AI model, and so and that all comes down to, when I talked about, it's all about training, right? We never had the opportunity to train the model because we never saw enough data to do that. And so that's the limitation of AI, right? So it's a technique that depends so much on data. That's how all the algorithms have been designed, that more data it sees. That's the reason why you notice that face recognition, image processing, we have done a good job, because now we have wealth of data. I think the social networks have all our images by now. And so they figured out how to do that, all because of data. Now, if they didn't have the data, that makes it extremely challenging. So yes, so unfortunately, AI is not, I'll go on a limb and say that AI will not be able to provide an accurate prediction on that, because it doesn't have the data. So a lot of the work going on in the cure, I'm pretty sure it's all proprietary, and it's shared in bits and pieces. And so that comes down to another huge problem with AI. How do AI algorithms handle with missing data, incomplete data? So it's got its limitations there as well. When the data is noisy, data is missing, and in the example of the cure prediction, most of us don't have all the data that's associated with where we are, and so there's going to be a lot of analysis that needs to be done. But I would say that any system that can claim that they can predict the cure is acting on limited data. So you can make some prediction. The biggest challenge is, how do you verify it, right? We have no way to verify it. And so, because we never seen something like this before, and that's why I keep going back to my last slide where you talk about coming up with verifiable AI model is extremely challenging. So anybody can throw out some number and hope that it sticks. But I'm sure they do that. And it's going to be a gross estimate, but we can't verify it.
Okay, thank you. On the opposite end of the spectrum, so let me try to pronounce this name. Trivishnu from India asks, with the exponential growth of data, how can an AI computing system handle it as it continues to grow? So when you have too much data and the data continues to become available, how can you make use of it?
That's true. And so that's another side of the thing. That's a big data problem. And so that goes into the question now comes about is that, do we have enough computing power to process the data? So the big tech companies do, that they have a lot of, and so you notice that Google of the world, they're able to dominate the space because they have a lot of computing power, a lot of storage power. And that's how they've been able to address it. So that becomes a challenge for a lot of people who want to get into space. I actually, I'm thinking as we move forward, we probably want to get to a world where we learn with less data. And again, this will require more work on, I can't just say learn with less data, because there has to be some way to capture the experiences, examples. So we need to work on the concept of universal knowledge. We need to capture some of the universal truths. If you look at the car example, if you think about human brain, the human brain is not constantly looking at every single thing happening on the road and determining how fast or how slow the human being should drive. So the human being already has experience and the knowledge. So we need to figure out how we can learn with less. But to do that, we need to come up with this universal knowledge. We need to capture some of the laws into our AI model so that our AI model can work like human brain, because even a human brain can't capture all that data, right? So you're going to have cognitive overload when all the data is presented to you. But we still make decisions. We still make decisions with important data. So the key piece is all the data that's being shared. How do we determine the important data? And that's another aspect to focus on. And how do we build this universal knowledge structure such that we can overcome the need to process all the data? But still, until we get there, the big companies who have all the computing power are going to be ahead, because they have the ability to store and compute and provide it, because they have amassed so much computing power that they'll be ahead of them. But I don't think that's the only way to address this problem. I think there is another way to do that. If you build some universal knowledge structure, that may be an alternative to get away from this continuous data-based learning.
Okay. Let me ask a couple more questions. We won't be able to get to all of them. Manuel Saldaña from Chile asks, what will be the impact of AI in Industry 4.0? Can you explain Industry 4.0 to the audience very briefly?
Well, I think that the industry, if you look at our progression of where we have been with the various industries that we have, we are talking about a knowledge-based industry. And so in the knowledge-based industry, what is going to happen is we will have to depend on the integration of data coming from all different types of systems. So we are talking about machine to machine, machine to human type of interactions. And so where the lines are blurred between what is physical and what is cyber. And so in that kind of world, how do we make sure that we can push the AI closer to the edge, right? So we need to have the AI capabilities to monitor all our devices, because there'll be so many devices with enough power that are more powerful than your regular computers. And so that's going to be enabling a lot of different things. And so we need to have AI systems that can tackle the information that is collected at the edge, whether it's in a power plant, whether it's in a healthcare facility, because we will be having a lot of sensors. And with Industry 4.0, we will be enabling smart cities, we'll be enabling smart ports. And that's going to create an environment where we'll be so dependent on sensors. Industry 4.0 is all about sensors driving the information flow. And so essentially what we're talking about is, with no human interaction, sensors being able to monitor the environment and do the analysis and exchange information with other sensors, and that's how services will be provided to us. And so our safety is going to be dependent on those sensors operating accurately, and we can trust those sensors. And so I use the word trust in AI, but that goes into the actual devices that are going to be responsible for collecting the data in our environment, making our city smart. And so that's one of my concerns, that the future smart city is going to be depending on Industry 4.0 technology. It's going to depend on sensors, it's going to depend on IoT, it's going to depend on AI. So the integration of all those is going to result in 4.0. But how do we make sure that the trust is there? So rather than use the word secure, if you don't trust the sensors, if you don't trust the algorithms that are running, then our safety is at risk.
Okay. I need to make a choice here. I'll ask a question from Adolf Basmenson Castillo. I think follows your current answer. Where do you see the next step for AI and machine learning as these technologies have become more refined? Where do you see them integrating into solving societal problems?
I would say that the biggest thing is, and I mentioned this earlier, about it goes into, I think this is going to be the next frontier, and this is going to be the hardest problem. How do we make sure the AI is fair? Because the biggest challenge will be AI influencing policy. And when we come to that stage where our legislators, our politicians, our policies that govern society are going to be driven by AI. So how do we make sure that those are fair and unbiased? This is a huge problem, because definition of fair is not universal. Who defines fair, and who's on what basis do you define fair? And when I talk unbiased, what bias am I talking about? And so coming up with a framework, because this is going to influence our policies. This might influence judicial reforms, right? So there are so much impact. Right now, AI is only impacting our computer systems and associated systems. But when it starts influencing policy that will govern the way we live, that's when I think it gets very interesting. And that's the next frontier for AI on how we tackle fairness and being unbiased. And so it's the jury's out on that, because we don't currently have a scientific framework to define fairness and to be unbiased.
Okay. Thank you again, Dr. Chidi. That was a very informative talk. I'd like to thank the audience for joining us, and I apologize for being a little late. It was my fault. I do want to invite everybody for next week. Dr. Shady, if you could please stop sharing your screen. So let me go ahead and share my screen over here. I've lost it. Share. Okay, so if you go to the REYES website, I encourage you to go to the news tab, updates and news tab in the REYES website. We have posted an introduction to week number 2. So here you have a short video to show you which classes and activities are being prepared for week number 2. If you have not registered yet for REYES, I strongly encourage you to please register using the register tab in our REYES website. And if you have any questions, continue to send them, and we like to try to answer them as much as we can. So we also have an FAQ where we ask the most commonly posted questions. So again, take a look at our introduction, and I look forward to see you again next week.